Hello everyone, it's September 26th. Alright, let's get on to it. Largest triangle area. Given an array of points on xy plane where points I, xy return the area of the largest triangle that can be formed by any three different points. Answer within okay, where points, so I have these points. When you return the area of the largest triangle that can be formed by any 3 points. Any 3 points. How do you even compute the area? Yeah, I think there is a formula to compute area given the Euclidean coordinate. I kind of forgot. I don't remember. But there is a way. Because I'm starting to think, because any 3 points can form a triangle. So I'm starting to think just 50. Right? We just brute force this thing. What's 50 choose 3? 50 choose 3. Combination. Yeah, it's not that much. Well, all points are unique. So, given some points, is there a rule to say which one is the biggest? Actually, I don't know. I mean, we can definitely get the ones on the outside. We can argue the ones on the outside. It's better to get the ones on the outside. Then we have to figure out how to get the ones on the outside. Well, we have the leftmost, right, moving in. Well, we can. We can get the ones, but I don't think that's the way to go, because I don't think it's trivial to get all the points on the outside. But even if you get the points on the outside, what you're gonna do? You still have to, like, I'm not sure. I feel like this is just brute force, right? I feel like this is just brute force. But I feel there gotta be a better way. Oh. What is a better way? I honestly have no clue. Or we can say if I fix one point, right, and then we need two other points. Now, if I fix 2 points, then this forms one side. Then we have, you know, all the other ones. So no, yeah, so we fixed 2. We need to find a third one. It's definitely gonna be the one furthest away, right? Because this line is deterministic, right? And just we want the furthest away on this direction. So it's either this one or this one, right? And depending on, yeah, okay. Feels common. I'm gonna brute force it. But how do you find the area based on the coordinates itself? I honestly have no clue. I don't know, man. Let's say if we want to find this one, right? How do you find the area of this one? I used to know. Okay, so here's one way. We can get the function of this line, and then we'll get its slope. Then we know this slope because the multiplication of them is, oh man, I completely forgot. What's the multiplication of the slope when they're perpendicular? I know it's either 1 or -1. I forgot. I think it's 1, right? Because, no. So this is 1, k is 1. This k is -1. Maybe it's -1. The multiplication is -1. I'm not sure. Damn, I can't believe it. How about this one? This is 1/2. So it's perpendicular to this one. This one is, yeah, it's a negative. Yeah, it's negative. This is a negative. Then it's -2. It's -1. Oh, so from that, we can get the slope of this, and we need to find this point. Oh my god, that's just... Do we have another way? Come on, there gotta be another way. Right, there gotta be another way. I just want to find this. Can we, well, we have this thing. This is a trapezoid, right? So we have 2 trapezoid. I know it's this line plus this line times this divided by 2. I need to check trapezoid. I forgot all of these things. Oh. Okay, so this is going to be b times d, right? This is going to be b minus a. B times d minus b minus a times d divided by 2. Two bd minus bd plus ad equal to bd plus ad divided by 2 equals a plus b times d divided by 2. Yep, this. So okay, so if this is, let's call it x0, y0. Let's call this as x1, y1. This is x2, y2. All right. Then well, this is that they're all above, because you can also have them not all above. So we need to have a base, right? We need to have a base. Well, let's say it's minus 50, right? So we can say minus 100. Okay, so here, this is your base, minus 100. We just extend all the way down, extend all the way down. Doesn't matter. So this, we can call it, so we can call it A, B, C, right? And you have this one is going to be D, this is going to be E. So A is going to be x plus 100, right? And even if you're here minus 50, yeah, that's still right. So A is that. B is going x1, x0. B is going to be what if it's what if it's like it's this one? Go down. Yeah, it's different. All right, if it's dear Lord, like this. It's a different thing. It's a different thing. Because here I'm going to be this, this, and this, this, and this, and then I need to minus this one. How'd you get to this one? You can't. What in the world? I don't know. What's the formula? Screw this. Okay, so this is x0, y0. Yeah. x1, y1, x2, y2. Alright, so the line, so the k should be y2 minus y0, x2 minus x0, right? But I do need a line. How do we get a line? Anyway, so that's k prime is x0 minus x2, y2 minus y0, so their multiplication is -1. So I need this, right? I need this line, the function for this line. So I have k. I need to get a b, because it's y equal to kx, right? Plus b. So y, I can just do y2 is equal to y2 minus y0, x2 minus x0 times x2 plus b. So we got b. Right, so this is going to be x2 minus x0, y2 x2 minus x0 minus x2 y2 minus y0. So this is x2 y2 x0 y2 minus x2 y2 plus x2 y0. So these goes. So that's the x2 y0 minus x0 y2 divided by x2 minus x0. So that is B. Okay, so first one we have. The first one is y equal to y2 minus y0 x2 minus x0 times x plus x2 y0 x0 y2 x2 minus x0. So this is one of them. Now we have another one. Basically we do y1 equal to x0 minus x2 y2 minus y0 times x1 plus, this is also a b, so we move, so equal to, so b will equal to y2 y0 y1 y2 minus y1 y0 minus x1 x0 x1 x0 plus x1 x2. So the second one is this. So the second one is y equal to x0 minus x2 y2 minus y0 times x plus y2 minus y0 y1 y2 y1 y0 x1 x0 x1 x2. Alright, so these are the two. Now I want to know what is the point, this point. What is this point? Because when I get this point, I can find out this. Right. So I put them together. So yeah, I moved this one here. So what we have is y2 minus y0 x2 minus x0 x plus 0 y x2 0 minus x0 y2 x2 minus x0. Actually, I don't have to rewrite everything. Yeah, I'm gonna delete all the other stuff, so give me some room to work with this stuff. Okay. Hold a second. We actually going to directly move them. So I put this on the left hand side. So this move here. So it's gonna be this minus x0 y2 minus y0. So it'll be this times x, right? So move this one here. This move here, this move there. So that shall equal to y1, y2, y1, y0, x1, x0, x1, x2, y2, y0, minus x2, y0, x0, y2, x2 minus x0. Holy crap. Anyway, this can give you x. Dear me. Yeah, this can give you x. Alright, I am not entertaining this. This take two. There gotta be an easier way. I don't know what the easier way is. I think there is some formula that you can follow, but I don't know. What is the formula? Yeah, you can compute the x, you can compute the y, then you can compute this, and you compute this. Yeah, maybe it's not that bad, but no. Let me search online. Maybe there is. So how to find the area of a triangle given the coordinates of each point. I forgot. Oh, this is the formula. Do you remember? I might remember this. Oh, it's called the shoelace formula. You know, AB times AC is a vector perpendicular to the plane ABC, such that AB times AC equal to area of the parallelogram of this. Thus, the area is equal to half of this. I don't know that. I know this is. I know this part. Okay. I don't know. There is a such that this is area of this. I do not know that. So this and this. So we deduce the area. Is this times this? Is this times this? Minus this times this. Ah, some shenanigan going on here. It is also the Heron formula. Oh, screw this. So we have ABC, right? So AB, BC, CA, AC. What the hell? So does it matter? I think this one is the clearest. This one is the clearest. x2 minus x1, y2 minus y1, x3 minus, yeah, this is this and this, and multiply. Oh, all right. I don't know how to do this. I am brute force this thing. Oh. Brute force. But I need internet I need some internet help to know how to find the area of a triangle given the coordinates of all three corners. The formula is as follows. S equal to 1/2 of ABS, right? Something times something minus something times something. And this is going to be, so x1, 1, 2, 3. So so this is x3 minus x1, and here is going to be y3 minus y1, right? And then is x2 minus x1, but because it's the cross, so it's going to be y2 minus y1, and this is going to be x2 minus x1. Let me see if it's correct. 2x2 minus x1, y3 minus y1, x3 minus x1, y2 minus y1. Okay. Alright, so that's that. That's all we need. And then what we're gonna do is loop through all possibilities. So for so have I equal to 0, I smaller than point. Let's go actually point dot size. Okay, so this is gonna be n minus 2, because n minus 1 minus 2, yeah, so n minus 2 minus 3, yes, and then this is going to be I plus plus. That's the first one. For int j equal to I plus 1, alright, it cannot be I, j smaller than n plus 1, j plus plus. That's the last one. For int k equal to j plus 1, k smaller than n, k plus plus. Alright, now I got all three. Then I need to plug it in. So I can do, x1 equal to points I 0, y1 is points I 1, x2 is points j 0, y2 is points j 1, x3 points k 0, y3 points k 1. Oh, we also need a double. Res equal to 0. Can res equal to maximum res, then 0.5 times, might as well just do all of them but double. Make things easier. Double, double, and double. Okay. So this times std abs something times something minus something times something. Alright, so we have 3 minus x1. This is y2 minus y1, y3 minus y1, x2 minus x1. And then at the end we'll return res. Alright, let's see how slow it is. That's not slow at all because we have very little to go through. But brute force. Alright, that will be it. It took way too long.